Hi there, let me show you a new persona on LoLLMs called Electricity Guru. This persona can help you in your electricity projects and can give you some advices to keep you safe from electricity hazards. Here I'll use it with GPT-4 vision model to ask it about a snapshot from ElectroBOOM video where he tests a capacitor with a high voltage. Let's import the snapshot image, then ask the question. What do you think will happen when he'll approach the wire from the capacitor electrode?
The classic scenario of man versus capacitor. If our friend in the image approaches the wire connected to the charged capacitor electrode without proper insulation or safety precautions, he's in for a rather shocking experience. Capacitors store electrical energy, and when discharged, they can release that energy quite rapidly. Depending on the voltage and capacitance, the result could range from a mild tingle to a dangerous shock. It's crucial to always discharge capacitors safely using a resistor or a specialized discharge tool before handling them. Remember, safety first. Always approach electrical projects with caution and respect for the power of electricity.
Okay, the objective of this guy is to create the biggest voltage he can by cascading capacitors and resistors with gaps. When they tick, at the end he can have a huge voltage and create the longest arc possible. Can you give some advice about this and how he can do it safely?
Certainly, Parisneo. Creating a high voltage cascade to generate a large arc is quite an ambitious project, and it requires meticulous planning and safety measures. Here are some tips on how to approach this safely. 1. Understand the theory. Before starting, make sure to thoroughly understand the concept of voltage multipliers such as Cockcroft-Walton or Marx generators, which use capacitors and diodes or spark gaps to step up voltage. Do use appropriate components. Select capacitors and resistors that can withstand the high voltages. Ensure that all components are rated for the maximum voltage you plan to achieve. 3. Insulation. High voltage can easily arc through air, especially at points of high potential gradient. Use proper insulating materials around all conductive parts to prevent unintentional arcing. 4. Safety barriers. Set up physical barriers or enclosures around the setup to prevent accidental contact with high voltage components. 5. Grounding is essential to safely handle high voltages. Make sure to have a good earth-ground connection to mitigate the risk of electrical shock. 6. Safety equipment. Wear personal protective equipment such as electrical gloves, insulating mats, and face protection to minimize the risk of injury. 7. Controlled environment. Perform the experiment in a controlled environment, away from flammable materials, and with proper ventilation to dissipate any ozone or nitrogen oxides produced by the arcs. That. Remote operation. If possible, operate the cascade remotely to avoid being in close proximity to high voltage components. During Operation 9, emergency plan. Have an emergency plan in place, including a clearly marked and accessible power-off switch. And know the location of your nearest fire extinguisher. Consult with the experts. If you're not fully confident in your understanding and handling of high voltage systems, consult with an expert or a professional electrical engineer. Remember, creating large electrical arcs can be extremely dangerous and should only be attempted by those with a deep understanding of electrical systems and safety protocols. Stay safe, and may your arcs be long and your shocks be non-existent.
Yeah, he is trying to build a Marx generator and he is trying to test a single capacitor. Here is what happens when he touches the capacitor electrode.
I see. When testing a single capacitor in a Marx generator setup, it's crucial to ensure that the capacitor has been properly discharged before attempting any physical contact with the electrodes. Touching a charged capacitor can result in a sudden discharge of electrical energy, which can cause a painful shock or even burns, depending on the stored energy. In the case of your friend, it's imperative that he, 1, ensures the capacitor is fully discharged using a bleed resistor or a discharge tool. A bleed resistor can be left connected across the terminals to automatically discharge the capacitor over time. 2. Verifies the discharge with a voltmeter to ensure that there's no residual voltage present before handling. Keeps in mind that even after a proper discharge, capacitors can sometimes build up a residual charge due to dielectric absorption. It's wise to double-check the discharge before touching the electrodes. By following these safety measures, he can minimize the risk of electrical shock and ensure a safer testing environment for his Marx generator project. Remember, electricity demands respect, and safety should always be the top priority.
It looks like the capacitor electrodes arced when he connected the second electrode to high voltage. Why?
In a Marx generator, each stage, including the capacitors, is designed to hold a high voltage until the entire system is triggered to discharge. If your friend connected the second electrode to a high voltage source and an arc occurred, it could be due to several reasons. 1. Insufficient insulation. The insulation between the electrodes may not be adequate for the high voltage applied, leading to a breakdown of the insulating material and allowing an arc to form. 2. Proximity of electrodes. The electrodes may be too close to each other. As the voltage increases, the electric field strength between the electrodes can become strong enough to ionize the air, creating a conductive path and resulting in an arc 3. Overvoltage. The applied voltage may exceed the breakdown voltage of the capacitor, which is the maximum voltage the capacitor can withstand before an electrical breakdown occurs. 4. Surface contamination. Dirt, moisture, or other contaminants on the surface of the capacitor or the surrounding area can lower the breakdown voltage, leading to premature arcing. 5. Sharp points. Sharp points or edges on the electrodes can concentrate the electric field, increasing the likelihood of arcing at lower voltages. To prevent this from happening, ensure that the capacitors and their connections are well insulated. Maintain an adequate distance between electrodes. Use components rated for the intended voltage. Keep all surfaces clean and dry, and avoid sharp points where possible. Proper design and maintenance of the Marx generator are key to preventing unwanted arcs and ensuring safe operation.
Here is the last photo. What can you say about this photo?
Based on the image provided, it appears that the individual is experiencing an unintended electrical discharge, which is commonly referred to as This can happen when high voltage is present and the electric field strength becomes strong enough to ionize the surrounding air, creating a conductive path for the electricity to travel through. This situation is highly dangerous and can result in severe injury or even death. It's a stark reminder of the importance of following strict safety protocols when working with high voltage systems. It's crucial to ensure that all components are properly rated and insulated, a safe distance is maintained from high voltage parts, and that one always wears appropriate personal protective equipment. To prevent such incidents, it's imperative to thoroughly plan and design the setup, always use caution, and have emergency procedures in place. If you are ever unsure about working with electricity, especially at high voltages, please seek the guidance of a professional electrical engineer or an expert in the field. Safety must always be the top priority when dealing with electrical systems.
He is a famous YouTuber with the name ElectroBOOM. He builds electric stuff and makes fun of himself being shocked. I like his videos, they are very funny.
Our ElectroBOOM, a well-known figure in the online community for his humorous approach to educating about electronics, while often intentionally and sometimes unintentionally getting shocked. While his videos are indeed entertaining and educational, it's important to remember that the stunts he performs are done with a deep understanding of the risks involved and should not be replicated without proper knowledge and safety measures. Always approach electrical projects with caution and respect the power of electricity. It's great to learn and be inspired by content creators like ElectroBOOM, but safety should always come first in your own projects. Enjoy his videos, but remember to follow proper safety protocols in your electrical endeavors.
To end up this session, make an artwork of Santa trying to build a Marx generator. I want this TI be colorful and depict Santa as a wicked scientist. I want his smile to be wicked and daring.
An artwork of Santa Claus dressed as a mad scientist standing in a cluttered workshop filled with electrical components. He is attempting to build a Marx generator surrounded by cascading capacitors and resistors with electrical arcs sparking around him. The atmosphere should be vibrant and chaotic, with a color palette of bright reds, greens, and electrifying blues. Santa's expression should be a mix of wickedness and excitement, with a daring smile as he adjusts his goggles and holds a soldering iron. The style should be whimsical yet detailed, capturing the essence of a holiday-themed science fiction scenario.
Add more sparkles to the image and make it more cartoonish.
An artwork depicting Santa Claus as a mad scientist with a wicked and daring smile working on a colorful Marx generator in a whimsical, cartoonish style. The workshop should be filled with bright reds, greens, and electrifying blues, with electrical arcs and sparks adding a sense of chaos and energy. Santa should be wearing goggles and holding a soldering iron, with his expression conveying excitement and a hint of mischief. The artwork should capture a holiday-themed science fiction atmosphere with added sparkles to enhance the cartoonish and vibrant feel of the scene. The title of the artwork should be Santa's Electrifying Experiment, the Mad Scientist's Holiday Workshop.
Thanks.
You're welcome, Parisneo. If you have any more questions or need further assistance, feel free to ask. Stay safe and have a great day.
Today we have learned how to use LoLLMs to load the persona of the electricity guru. Use vision to comment few frames from a YouTube video. Use more than one agent in the same discussion. Use the new xtts text-to-speech to synthesize voices. Generate some images in 2 steps. Learn something about capacitors. The video frames we have discussed in this video are taken from one of ElectroBOOM videos. Make sure you check them out. They are very funny and instructive. As said before, ElectroBOOM is a professional, so don't try to replicate his experiments as they can be quite dangerous. The voice used for the electricity guru is inspired from ElectroBOOM voice without his accent. So you now know how his voice can sound like if he had no accent. The xtts system automatically modifies the voice a little bit on purpose to prevent full voice cloning, as the purpose here is not to clone exactly the voices but to get a voice that is adequate with the persona and not pretending that this is the voice of a real human. I think here the voice difference is very noticeable, but make sure you only use voices that you are allowed to use or are very different from the original ones. I hope you liked this video. If you did, please make sure you like, share, comment and subscribe to get notified of any new videos. Thanks for watching. See ya.